Hey guys, welcome back. Here we are going to start the next topic, and that is called the isotopes of chlorine. Rather, I must say this thing that we are going to continue the topic of isotopes. In the previous lecture, we have discussed the isotopes of hydrogen, and then we have prepared water by using different isotopes of hydrogen. Here we are going to continue at this same topic with isotopes of chlorine. There are basically two types of isotopes of chlorine. So, number one is chlorine 1735, whereas the other is chlorine 1737. Okay, so what is the similarity and what is the difference? Okay, if we are talking about the proton number, both of them have the same proton number, and that is 17 in this case and 17 in this case. What about the electron number? Yeah, electron number will be same as well, and that is 17 in this case and 17 in this case. But what about the neutron now? The problematic thing regarding isotopes? Yes, it is 35 minus 17, which is equal to 18, whereas 37 minus 17 is equal to 20. Okay, so this is the 20 number of neutrons here, whereas 18 number of neutrons here. So we can see this thing very, very clearly that both of them have same proton number, same electron number, but different neutron number. Okay. Now come towards the next topic related to the same isotope. I mean to say one more information related to isotopes, and what is that? It is the effect of the difference of the number of neutrons on the number of chemical properties and on the physical properties. Okay. Now the point is this, that what are chemical properties? I am going to write here chemical properties are basically chemical reactions only. Okay, chemical reactions only. Now one thing which you should know is this, that chemical reactions are only based upon number of electrons. And on which number of electrons? The outer shell electrons. What is the meaning of the outer shell here? I have discussed with you in this electronic configuration thingy that these are the electrons in the first shell, these are the electrons in the outer shell, these are the electrons in the first shell, these are the electrons in the second shell, whereas these are the electrons in the last shell, I mean to say the outermost shell. So when we are talking about the chemical reaction, we must say this thing, that chemical reactions are based upon the outermost shell electrons only. Right now, you can keep this thing in your mind, that chemical reactions are based upon the outer shell electrons, or you may consider electrons only. Okay, so we can say this thing very clearly, that here chemical properties, which are also called as chemical reactions, are based upon electrons only. It means that in case of isotopes, the chemical reactions will be same. And why they will be same? Because they have the same electron number. As their electron number is not undergoing any change, so we can say that their chemical reactions will be same, their chemical properties are similar. Okay, now I am changing the board and we are on the next board. Right now we can say this thing, that for example, what about the physical properties? Okay, physical properties, we can say right now that in case of physical properties, which are, what are the physical properties? First of all, it is melting point, it is boiling point, it is density, it is solubility, it is electrical conductivity, solubility, ability, okay, and electrical conductivity. Okay, so all these are physical properties, and these are based upon the nucleon number. Nucleon number. So what is nucleon number? It was the sum of protons plus neutrons. Okay, so it means that involvement of neutron is there. Yes, involvement of neutron is there. So that's why we are saying that in case of isotopes, the electron number remains same. It means that chemical properties remain same, but as their neutron number is changed, so we can say that they are different in their physical properties. Okay, so they have different melting points, different boiling points, different level of solubility, different electrical conductivity. Now what is electrical conductivity? It is the ability to to conduct electricity through it. So they have the different ability to conduct electricity and different solubility in water or different solubility in other solvents as well. Okay, solvent is something which has the ability to dissolve an other compound. Okay, so as water is capable to dissolve sugar in it, as water is capable to dissolve salt in it, so we can say this thing that water is one of the solvent, one of the very important solvent. We will discuss this topic of solvent, solution, and other terms related to solubility later. But right now, I'm just telling you that in case of isotopes, they have similar proton number, similar electron number, but different neutron number. Okay, so after discussing this thing related to isotope, I am going to take you to a very important part of the same topic, and that is called as calculation of average atomic mass. Now, what is average atomic mass? Okay, so for example, we can see this thing that there are three isotopes of hydrogen. One is 1H1, the other is 1H2, and the third is 1H3. Whereas in case of chlorine, one is 1735, whereas other is chlorine 1737. Okay. So where this chlorine 1735 is written in the periodic table? It is not written. Okay. So there is something fishy. Yes, we are going to look into this something fishy. Okay, this mystery we are going to unlock. The other isotope of chlorine is chlorine 1735. Okay, so one is 37 and the other is 35. Both of them are not mentioned in the periodic table. Which is mentioned in the periodic table is chlorine 37, not 37, not 35, rather chlorine 1735.5. Okay, so from where this chlorine 35.5 has come. So it means that some average atomic masses we are going to calculate, and how we are going to calculate those average atomic masses, this is the point which we are going to discuss right now. Okay, uh, let me find out another page. Okay, so here I'm writing the heading is average atomic mass calculation. Okay, how we can calculate the average atomic mass. Okay, so there is a formula for this, and that is average atomic mass is equal to mass of isotope number 1 multiplied by percentage of isotope number 1. You may say abundance. Okay, so I'm going to write this thing as well. Percentage of isotope number 1 plus, here is the plus, very clear plus. I'm trying to write with another color. Okay, and then we can write with another color here. Mass of isotope number 2 multiplied by percentage of isotope number 2 divided by 100. Okay, so what is the mass of isotope number 1? Let's consider I am writing here the two isotopes of chlorine which I have mentioned on the previous page. One is having the mass of 35, whereas other has the mass of 37. Okay, so we are going to consider these. So one is, we can consider this as number 1, we can consider this as number 2. Okay, now we can see this thing that number 1 is mass of number 1 is 35, whereas its percentage is 75%. Now the point is this, that how I will know this thing, that what is the percentage of one of isotope where this percentage is present. This is the total percentage of chlorine 35 present in this whole universe. Yes. So do I need to know how to calculate this? No. Should I know this thing? What is the way to calculate this? No. Will examiner ask me any method to calculate this? No. So what is this? This 75 is calculated by list of experiments, and scientists have invested lots of years in investigating the percentage of each of isotope. So scientists have calculated this thing, that percentage presence of chlorine 35 in the whole universe is 75%. Okay, so then we can say it is with the plus sign, and now we can change the color so that you may not confuse this. And I'm back with the black color, mass of isotope. Okay, so what is the total percentage of something? So total percentage is always 100. So if we know this thing, that percentage of one of the isotope is 75 out of the two isotopes, so automatically the percentage of the other isotope will be 25. So mass of isotope number 2 will be 37, and it will be multiplied by the percentage of isotope number 2, and that is called 25%, and we are going to divide it by 1000. When we are going to calculate the answer, the total answer is 35.5. Okay, so this is the way to calculate the average atomic mass of any isotope, of any element. Okay, so we are right now going to calculate the average from all the isotopes. So we are going to say this thing, that in the periodic table, masses of average atomic masses of all the elements are taken. Okay, so for example, one mass is given with uranium. For example, one mass is given with cobalt. For example, one mass is given with hydrogen, for example. So all these masses are the average atomic masses. Okay, scientists have taken the masses of all the isotopes of an element, and then they have used this method to calculate the average atomic mass. Okay, we are going to implement this thing on the next isotope, and that is of chlorine. Okay, so here is for chlorine. For example, we for hydrogen, sorry. So chlorine is done. So average atomic mass calculation for hydrogen. So as we have used a formula, and for chlorine, we have used this formula for 2 times. Definitely, we are going to use this formula for hydrogen for 3 times. Okay. So for example, average atomic mass is equal to what? Is equal to, we can consider the mass first. Okay. So mass of number 1 multiplied by percentage of number 1 plus mass of number 2 multiplied by percentage of number 2, and then plus, as there are 3 isotopes, so we are going to take this with the red again, mass of number 3, and then multiplied by percentage of number 3 divided by 100. Okay, so what is the mass of number 1? Okay, I'm writing here in this box. So for example, we are saying that there are 3 isotopes of hydrogen. What are those 3? I'm going to mention that. Okay, so one is here I'm writing with another color. Okay, so one is 1H1, the other is 1H2, the third is 1H3. Okay, now I'm saying you to find out what is the mass of number 1. It is number 1 is mass is 1, whereas its percentage is 99.9. Okay, 99.9. Okay, whereas the percentage of the next one is, mass is, first of all, mass is 2, whereas percentage is 0.06. Okay, and then we are going to add it again with the mass of, obviously, now what is the percentage left? It is 99.9 plus 0.06. When this total will be subtracted from total 100, it will be 0.04 automatically. Okay, so this is now, it is 3 multiplied by 0.04, and the total is divided by what? Total is divided by 100. Okay, so I am going to divide it by 100. The total answer is 1.0003, something like that, which is nearly equal to 1. Okay, so you can calculate it and you can prove this thing, that it is nearly equal to 1. So that's why this 1 is written in the periodic table. That's why this 35.5 is written in the periodic table. Okay, So these two calculations are the proof that you people can estimate that it is the average atomic masses from all the isotopes of an element written in the periodic table. Okay, so this is the concept which I was thinking to clarify in your mind, and you people can correlate these two isotopes with each other. You will find the same information regarding both. Now I am telling you that there are two types of the questions related to isotopes, and one is to calculate average atomic masses from given percentages. Number two, to calculate percentage of an isotope from given from given atomic masses. So this was the target number one, which we have already achieved. Okay, so how to calculate the average atomic mass from the percentages? One thing which I would like to clarify, that percentage is equal to abundance. What is the meaning of abundance? That how much it is present in the universe, total presence, you may say. Okay, so percentage or abundance or the total presence is something which is already calculated. And here sometimes we have to calculate the atomic mass from the percentages, and sometimes percentages from atomic masses. So it can be one way or the other. Okay, so I have just taught you one of the thing, that is to calculate the average atomic mass from the percentages were given and we have calculated that. Now I am on the next point, and that is related to the concept of calculation of percentage from given atomic masses. Okay, let me change the board, and here I am on the new page. Okay, so for example, X is an element. What is the element? X. Okay, let's suppose that X is the element. Okay, X has two isotopes. One has the atomic mass of 152, whereas the other has the atomic mass of 154. Okay, and then they are saying that its average relative atomic mass is, I would like to explain this term of relative, which I am taking again and again. I am going to explain this thing right now. So its average atomic mass is 153. Okay, and then now examiner is asking calculate the relative abundance of each of isotopes. Okay, so we don't know its abundance and we don't know its abundance as well. Okay, its abundance as well. We will use the same formula. Okay, and what is that? It is relative atomic mass. I will explain this term of relative. I am informing you again and again. Relative atomic mass is equal to AR of number one. Yes, I'm going to explain this term AR, and then abundance of number one. Okay, or the percentage of number one. Okay, and then we can say plus AR of number two, and then multiplied by abundance of number two. Here I'm changing the color so that you people may not get confused. Okay, and it is divided by 100. So this will be 153 is equal to 152 times n. For example, its abundance is considered as n. For example, you may consider x as well, plus 154 times 100 minus n divided by 100. So it's a simple mathematical calculation. So it will be multiplied by on both sides. So it will be, this is 100 multiplied by on this side, whereas this is 152n plus 15400, as it is going to multiply inside the bracket, minus 154n. So we are going to find out the difference between what between 152n and 154n. And what is the difference? It will be minus 2n, as minus value is bigger, plus 15400 as it is, and this is 15300 as it is. So right now, what is the next? We are going to shift this 15400 on the other side. It will be with the sign of negative because it is positive on the that side, and when it will be shifted on the other side of the equality, it will be with the negative sign, and it is minus 2n. Here I'm doing the remaining working. Okay, so the difference between the two will be minus 100 is equal to minus 2n, whereas n is equal to what? N is equal to 50, because 100 will be divided by what? 2. Minus will be cancelled by minus. As a result of that, what will happen? As a result of that, the answer will be 50. Okay, so this is the point which I was explaining you right now. Okay, so you people can consider this thing, that what is the percentage of one of the isotope? It is 50%. And what is the percentage of the other isotope, or the abundance of the other isotope? It is also 50%. Okay, so this is the concept which we have calculated from this question. Examiner can give you the abundance, can give you the percentage, can ask you to calculate the relative atomic mass. Examiner can give you the relative atomic mass and can ask you to calculate the abundance or calculate the percentage. Okay, so these are the questions. This is the way to solve them. This is the way to handle the questions of relative atomic masses of isotopes. Now, before finishing this video, I would like to explain the term of relative. What is the meaning of relative? Okay, so there are two terms which you people should know. One of them is AR and the other is MR. So what is this AR and what is this MR? This AR is the relative atomic mass. I will tell you the exact, correct, and the very, very accurate selection of words. I mean to say the definitions of AR and MR. I will definitely, inshallah, inform you that. But right now, I'm just giving you a basic idea. What is AR? It is relative atomic mass. It is relative atomic mass of an atom, of an element, compared with 1/12 of carbon 12, as the mass of an atom of an element is compared with 1/12 mass of the carbon 12. Carbon 12 means that carbon having mass of 12. Carbon has a mass of 12. Okay, carbon has different isotopes as well, but we are talking about which isotope? Carbon 12. Carbon has an isotope of carbon 13. Carbon has an isotope of carbon 14. So you people might have heard this term of carbon 14 to study the ancient things, archaeology, and all these processes. So this is called as carbon dating, and it is used with the help of carbon 14 and etc. So this is one of the isotope, but here we are considering carbon 12 as a standard. So what is AR? Relative atomic mass of an atom of an element compared with 1/12 of the carbon 12. Okay, so as this is a compared value, as the masses of all the elements are the compared value, so that's why we can say this thing, that it is a relative atomic mass. Related, relative, compared. Okay, so that's why it is a capital small r. It means that atomic mass which is relative. Okay, whereas what about the other, that is called as the molecular mass which is compared. So we can say relative molecular Mass. And what is the answer? It is the mass of more than one atom of an element or different elements compared with 1/12 of carbon 12. So it means that when we are going to compare the mass of more than one atom of the similar element or the different elements, then it will be called as the relative molecular mass. Okay, so for example, just consider 35.5. Okay, so this is the mass of an atom of chlorine compared with 1/12 of carbon 12. Okay, so what about, this is called the AR value. Okay, and what about Cl2? It is 35.5 plus 35.5, so the total will be 71. So 71 is no more AR, rather it will be called as MR value. Why? Because it is more than one atom, either similar atom or different atoms, either similar element or different elements overall. Okay, so for example, if we are saying NaCl, we know this thing that Na is 23 in the periodic table, its mass number is 23, whereas Cl mass number is 35.5. So the total will be 58.5. We can say this thing that 58.5 is the MR value. So it means that it is a relative molecular mass of this sodium chloride, which is compared with 1/12 of carbon 12. Okay, so this is the term of relative, which is MR and AR linking with, and here we have completed the whole detail related to isotopes. All the best. May you all rise and shine in chemistry due to this channel. Thank you very much. Take care.